Okay, so what we're going to do today is, well, a few things. We're going to continue talking a lot about processing of text, and in doing so, we're going to be using both strings and lists in various ways. Okay, so we'll kind of continue the discussion of that. And if we want to process large quantities of text, then something like the SpongeBob assignment, where it was you prompt the user for the input, okay, of a string of, whatever that the user types in, but that's going to be a relatively small amount of data, right? A sentence or so at most. So how could we deal with vast quantities of text? No, don't need bigger computers, but we wouldn't be prompting the user to type them in. What we would be doing instead is accessing a file in which all that text already is, okay? So how do we do file access, basically, and get data out of a file? And we've already actually done this in one instance, which is to say when we did the Warhol, the image stuff, right? You were opening an image file, and then you weren't manipulating the file, but you were manipulating the data that was loaded into memory, in that case, just to make things look colored and kind of like the Andy Warhol prints. But you weren't actually editing the file itself. You were just opening it for read. But we can also write to files. And writing to an image file, well, that's going to be a little bit more complicated, of course, because we've got to know the format in which this stuff is stored, or have a library that kind of just magically handles everything for us. So the easiest place to start in terms of files would be files that just contain text. Okay, those are the simplest things that are encoded, and there's of course a plethora of just text that we can find online. Okay, and so I'm going to start with an example. Let's just process some text that we can find online, and basically we'll just dump something into a text file. And I want to look briefly about how that text is encoded in the file, and then we'll look at how we actually process it, okay, or how we could process it. So that kind of makes sense? Okay, so where do you get large quantities of text to do something with? Well, we could just basically copy and paste from anywhere. And, I could take, say, the Wabash College fight song or whatever. But a really good place if you want large quantities. How many of you guys have ever used Project Gutenberg for anything in another class? Okay, so this is an online catalog, basically, of free books. Now, these things a lot of them are the classics, right? But things that are well outside of copyright. Or things where, the author has decided to not put in copyright. So what's a classic book that we might want to deal with? That's something that's, maybe at least 100 years old. Gilgamesh, that's a great one. At least 100 years. Well, okay, so that's actually an interesting point that I need to click the button here, that you said Gilgamesh, because, why is this not loading? Okay, well, there it goes. So with respect to Gilgamesh, okay, and in this case, they only have one version on here, and I'm going to download the plain text UTF-8, okay, which is all here. And in this case, I'm also going to, when we download this, I'm going to copy or, remove any of this introductory stuff. Although, you know what, this actually seems to be a book about Gilgamesh, not the text itself. Oh, okay, actually, yeah, so this is more of like a scholarly book because it's got the transliteration of the actual Old Babylonian. Oh, no, and it does actually have some text here. Okay, so, Gish sought to interpret the dream, spoke to his mother. My mother, during the night, I became strong and moved about among the here, blah, 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 blah. Okay, so good example. but even though Gilgamesh, right, the story is thousands of years old, this particular translation may be newer, and obviously is much newer than Gilgamesh, but it could be the case that a translation of Gilgamesh is still within copyright, even though obviously Gilgamesh itself is not. Okay, okay. So let's not use this one just because it's got it's not quite what we wanted. So let's also do something older. Okay, Frankenstein. Yeah. Let's just do the Odyssey. Okay, and this is a particular translation. Okay, I think it says Pope here. I'm also pretty familiar with the Butler translation. Those are both free ones. Okay, so right. So anyway, it's going to have some sort of introduction, and I'll delete that because we don't really want to do any processing with that. But you know, here we go. You know, oh man, this one's weird. He did it in actual like poetry. Yeah. Okay. I don't like that version. Sorry. Maybe I'm a little bit of a snob here, but um, here, let's do Samuel Butler since he's the guy who translated it. Okay. This is, yeah, but I want to do the Iliad, even though I like the Odyssey better as a story. Yeah, this one will work. Okay, whatever. I don't need to be this picky. Okay, so let's just take this and I'm going to right click to save it. If the right click, oops, that's not the button I meant to do. Right click, save as, and I'm going to save this to my GitHub thing, and I've made a folder called files, and I'll just call this oops. I picked the Cowper, yeah. Okay, so all right, and now let's do a little bit of pre-processing. So I'm going to open this with the text editor here, and just basically get rid of all of oops, the stuff at the beginning, right? So all of the preface and any of that business. And editor's notes and all of that stuff. So, okay. And just for giggles, let me also only get, you know, just a small part of it, book one. So I'm just going to delete all of this. Okay. And then also, let's just take, I'm going to scroll down a bit and just take really a selection of it. Okay. So we'll take, say, this first. Yeah. Oh, so this is just in a text editor, right? So if on a Mac, you open it with text edit, on Windows with Notepad, and then you can just do it. Now, you also see that it's got some line numbers and stuff here. So let me first paste this, and let's go through and remove any of these line numbers and any of the things in brackets, which are footnote references. Oops. Oops. Okay. Comma. That gifts. And we could probably write a program to actually handle this to remove all the footnotes and things. But I'll just do that manually for the sake of time. And this is the only reason that I just wanted to pick sort of a small chunk of the Iliad for sake of demonstration. And this really could be any text of our choosing. Oops. Okay, so hopefully I got all of the different little like footnote things and the line numbers, and if not, it's okay. It'll be, so let's call this GitHub CS-111 files, and we'll call it Iliad, oops, Iliad2.txt. Okay, good. So that's the one that we'll actually process, just because it's a little shorter, no big deal. Oops, and there's a footnote. This is a different one than Butler. Yeah, I just grabbed whatever I could find. Butler one is the one that I first read, so yeah. Okay. Anyway, it doesn't really matter which text or which translation we're working with here. All right. So let's first off, I want to talk about how this data is actually stored. And to do that, let me actually go into a console. And on Mac, you're not going to be, I mean, on Windows, you're not going to be able to do this unless you have, I think, a PowerShell. And okay, so I've got Iliad2.txt. And so what I'm going to do is a hex dump. And then I'm going to blow this up so you guys can see it. Okay, so I've done what's called a hex dump of the file, which basically just shows me all of the bytes of the file. And I use the -C flag here. It's capital C, not lowercase c. And that gives it, that's basically a formatting option for how I wanted the information displayed. I wanted it displayed byte by byte. The capital C stands for canonical. So this is just like a way of displaying it. And for text or something, this is the way I prefer to look at it. Because over on the right, it actually decodes it to text, and so I can actually see what's what, right? So the first line that's displayed here is not the first line of the actual text file. The first line that's showed in my hex dump is just the first 16 bytes worth of that file, okay? And how is this encoded? So the first byte here is 41, and that's in hexadecimal, not decimal. What is 41? What does 41 represent? It's the capital A in ASCII, right? And then the next one, 63, is the lowercase c in ASCII, and so on, okay? So all of this text is encoded in Unicode UTF-8, which is for regular Latin text, is the same as the first part of ASCII. If you want to do proper Unicode, and if we have some time, I'll actually show you another example that I did with this. We could use the exact same program to process this text in ancient Greek instead of in English, okay? But the encoding will look a little different. Okay, so great, there we go. So how do I know where a line actually ends in the text or in the file? We have to look for something special, okay? So there's several special characters in ASCII. One of them, 20, is the space, okay? We've also got some punctuation marks like the comma or whatever, but we need to look for where is the actual break in the line, okay? It occurs right here, and it's displayed it here with a dot just to indicate that. But if we look at the corresponding character, it's 0A, okay? And if you pull up an ASCII table, you will find two characters that have to do with basically end of line, okay? End of line and also carriage return, 0A and 0D, okay? Now, because I'm on a Unix-based system, Linux in this case, or if I was doing this on my Mac, it'd be the same thing. On Linux or Unix-based system, lines are broken with 0A only, okay, just a line break. On Windows, they're broken with 0A followed by 0D, usually. Yes, and that's annoying, okay? So end of line followed by a carriage return. Okay, now what, maybe I got on my soapbox about this. What's the difference between end of line and a carriage return? Yeah, okay, and it's partly that, but it's also even older than mere DOS, newfangled DOS. It's because of this is how it is on typewriters, right? So moving the carriage back to the left on a typewriter is not the same as moving to the next line. To keep typing, you have to move the carriage back to the left and advance the paper reel to move to the next line. Okay, and on Unix systems, right, we haven't used typewriters for I don't know how long, and so yeah. Okay, so that's one possible difference between text editors in Windows and on a Mac that has caused significant headache in several of my classes. Okay, and that by the way, how you end the line wasn't always standardized. So on the Commodore 64, it ends in 0D only, just to keep everybody on their toes. Okay, so line breaks, right, are something that we have to think about, and that's how they're encoded as a particular byte in ASCII. And it's either going to be just 0A on Unix-based systems or 0A followed by 0D on Windows-based systems, generally speaking. Although, if you open one that's encoded one way on a modern Windows system, it's going to read it just fine, so you don't really have to worry about it. But that is an irritation that you might run into. Okay, and then otherwise, so what is this? It's just a crap load of ASCII, right? So I've got all this text. We figured out how it's encoded. What can we do with it? We could do all kinds of questions like that, okay? Now, maybe figuring out how many lowercase a's there are isn't particularly useful in this instance. If we were trying to do like decrypt something, then maybe doing that would be useful for frequency analysis. Okay, but if we can count the individual occurrences of a single letter, well, we could do the exact same thing and count the number of words, or even figure out for every word that's in this file, how many times does it occur, right? So, for example, Achilles, you might guess that his name comes up a little bit in the Iliad. Yes, he is the main character. He's the subject of the whole story. I mean, essentially, what is the whole story about? The first line tells you, or second line. Yes. And the very first word in Greek, in fact, is the rage, menin, right? Who else has taken Greek besides me and Thomas? Anybody else? Yeah, the very first word of the whole poem in Greek is wrath, menin, or rage, or you could translate it either way. But yes, sing, O goddess, the rage, the wrath of Achilles that brought untold woes upon the Achaeans. What untold woes do you have?
I have 0D and 0A.
Really? Interesting. So what did you dump it with? No, but the editing.
What do you mean?
You put
IW get
UW got it. Okay. I wonder then if when I copied and pasted and saved it, it changed the encoding. So I bet yours is just what the original was. Okay. Yeah, because UW got, so you just got it as it was. Yeah. Okay. And I edited it when I copied pasted just to have a smaller chunk of it for sake of demo. Okay. So good point there. All right. Yeah. So we could, for example, go through and count the occurrences of every word. Right. So we could count just how many words there are. That's a good question. And you guys use that kind of functionality all the time when you're writing papers, right? So, you know, if the professor says you need to write a 500-word essay, then what are you doing? You're going through and finding every, you know, you do word count like in Word, right? It gives you the word count, and then you go through and you're like, okay, I've only got 478 words, so let me change all the contractions to be uncontracted, and that'll get me another 20 or whatever, right? I agree, but yeah. So anyway, right? So that's something that you guys use all the time. It's just a plain old word counter. But let's spice this up a little bit and count the number of occurrences of all of the different words that appear in this chunk of the Iliad text. Okay, so essentially, right, what we're going to be doing is what people call digital humanities, right? So why might it be important to count the relative frequency of words that appear in a text? Well, yeah, I mean, but this is Homer, right? It's copyright doesn't mean anything here. But you can discover things about the style of text, the style of writers, and in particular, this may be in the case of Homer. If we looked at this in Greek, right, we could actually get a sense for the style of different authors because some of them are going to use different words in different ways, more frequently, less frequently than others. Okay. And that may not be borne out in our analysis of the English here because this is a translation. So there's sort of a layer of change there. But we could, yeah. So but doing this can really answer interesting questions linguistically, literary things. But the tool that we're going to use to do it, right, is some programming, right? Okay. So this is one of these hashtag liberal arts college moments. Okay. And then we'll do it with the ancient Greek version afterwards, right? Just for fun. Okay. So let's get to it, right? So I want to make a new file here, and let's call this text processing.py. Okay. And the first thing I need to do is I need to open the file. Okay. And the way I'm going to do this is I'm going to say input text equals open, and then I need to specify the name of the text file, which in our case is iliad2.txt, and I also need to specify how I'm going to open this file. Okay, so what does the R mean? Yeah, I'm opening this file for reading, not for writing. Okay, I could also open another file to write things to, and we'll look at that later. But for right now, let's just open a file for reading. Yes. Right, and we'll add that on at the end, basically after we get some stuff working. First, we'll just print information to the screen, and then we'll replace that with printing information to another file. Okay, but this way we're just doing one thing at a time. Okay, the other thing I need to do, and I'm going to go ahead and do it now, is we also need to close the damn file. Okay, and that needs to happen, of course, when we're finished with it, which I'll put down there at the very end. Okay, never open a file without turning around and closing it. Okay, thank you. Yeah, so just add in the close tag and do it now. So that bad things don't happen. Okay. Now, what I need to do is we need to figure out how can I get a line of text out of this file. Okay. And if I can get one line of text out of this file, then I can get lots of lines of text out of this file. Okay. And so I could do the following. Okay, so for line in input text, I'm going to iterate over all of the different lines of the file. Okay, and let me just, for sake of demonstration right now, let me just print the different lines. Okay, so what are we going to get dumped into the console here? a whole bunch of text. Okay, and let's just run that. Oh, and by the way, your terminal has to be where? You have to be in the same subdirectory that the text file occurs in, because otherwise it can't find it. Okay, and once this dang thing loads, decides to load today, come on, let's go. Okay, why is it taking so long to load the Python extension? Okay, you know what? I don't have time for this, so let's just do it manually. Okay, so what did it do? What did we do? We just printed line by line a bunch of text. Question, Thomas. I'll look at it in a second. Okay. Yeah. Now, why is this appear double spaced? By the way. Well, it is, but so it's convenient that it did. But why did that happen? Yeah. So the print command automatically puts an end of line character at the end of something you print. So it hits enter, but every line of my text also has an end of line character at the end of it. So we're getting two of them, and that's why it appears as double spaced. Okay. Which, okay, maybe isn't what we wanted here. But yes, okay. So the next thing I'm going to do is I'm going to do something. Let me do, instead of doing, all right, so let me say this line words equals line dot split. Okay, and then I'm not going to print the line, but this line words. Okay, now this split function, so when you get a line out of a piece of text, what is that? It's a string, right? And it has words and stuff in it. It also has spaces, it has commas and other things. And the split command can basically take a string and carve it up into a bunch of substrings that are going to be put as entries into a list. Okay, so let me comment this part out, and let's just do it for an example, right? So let me say my string is sing, O goddess, the wrath of Achilles, son of Peleus. Okay, all right, now let me do my list equals my string dot split, and then I'm going to print my list. Okay, and let's see what this does for a single, and of course the stupid Python thing is, okay, so here's what we get if I do the split thing on an individual string. And I'm going to think of this as just being one of the lines of the poem, and we'll iterate over those to do this for all the lines. So what do I get here? What did this produce, this split function? It produced a list whose members are strings, and each one of those members is one of the words. Basically, it split the string into a bunch of words. Okay. Now, you'll notice it didn't really do it perfectly. Namely, what? What does sing have? Sing still has the comma. Okay. So the split method isn't foolproof. Okay. And you can actually specify what characters to use as delimiters, meaning to force it to split there. This, by the way, is how, well, okay, what's another text-based format that might be really useful if you're doing, oh, I don't know, sports analytics, Mark? Okay, Excel, but what's maybe even quicker and dirtier than Excel? Comma separated values. Okay, a CSV file, right? So what is a CSV file? Excel for Excel for idiot. It's just a file format. It's not a program, right? No, right. It's just a dump of data, right? So a CSV file is just a bunch of numbers stored in ASCII in a file, and they're delimited with commas because we don't use a comma when we write down numbers. Well, okay, at least we don't here in Merca. They do in other countries. Um, yeah, and then the decimal points, you don't split over those because, well, that's where that means the decimal point, right? So we can do the same kind of thing starting with numeric text from a CSV file rather than word stuff. Okay, but the comma, right? Do we want the comma to be in the word sing if we're going to try and count words? No, because some instances of the word sing might occur with a comma and others might not. And we really should group those together. Yeah. Yeah, we'll have to worry about that. And I'm going to deliberately not for the moment um, for the following reason. There might be instances where a word in lowercase and a word in uppercase both appear and actually mean something different. Okay, so you're right. If the word sing, right, could occur both as uppercase here because it starts the sentence, or lowercase someplace else because it's just in the middle of the sentence. Okay, and so in that instance, yeah, I probably would want to classify those together. Okay, but what's a word that when it's in uppercase means something different than if it's in lowercase? Okay, God maybe. Although we can play a little fast and loose with that here because there's multiple ones. Any other words? Okay, yeah, you're getting quite biblical there, right? Uh, well, or yes. Okay, so sorry, I thought you were meaning the apple, right? Okay, I was going a little. I mean, we're doing ancient stuff, right? So my mind is in the BCE era. But yeah, capital Apple for the company versus lowercase apple for just the fruit should be treated as two different things, even though they're kind of the same word. And we could spend an hour coming up with lots of examples of that. Okay. Google maybe is another one, right? Because Google is a company is different than Google is in the very, very large number. Okay, so I need to get these commas out, but if I can do this for one line of text, can I just do this for a lot of them? Sure, okay. So instead of doing this split on a single line like I've done here, let's just do this and iterate over all of them, okay? So do you guys mind if I delete the example list? Is that okay? Okay, and then let's uncomment this out. Okay, and I'm not going to print, I'm going to remove the printing here and not do it every line because that's going to print, of course, a whole crap load of things. So what I'm going to do is start to build, okay, build a very, very large list that's going to have every word that appears in the thing, in the text. Okay, so I'm going to call this list of words. And it's going to start as an empty list because I haven't done anything to it yet. Okay, and then what I could do is this line words is itself a list that has however many things in it. Can I go and one by one take a word that appears in the current lines list of words and add it to my large list of words? Yes? Okay. And the way I'm going to do that is I'm going to iterate over the words in that line. So I'm going to say for word in this line words, list of words dot append, And what am I going to append? I'm going to append the word that I just found. Okay, so you know how we used the plus symbol with strings to basically concatenate two strings together? Okay, how do I add a member to a list? Concatenate is not really the right term here, but can I just tack one on to the end of the list? Okay, and I do that with the append method. Okay, so all that does is just going to say, if I have a list and it's got 5,000 things in it, and I want to append something, bam, I just tacked on the 5,000 at first. Okay, and I'm just going to keep doing this word by word by word until I hit the end of the file. Okay, so is that okay? Yeah? So, list of words is going to be a gigantic list whose entries are every word of this text in the order that they came, right? So, for example, the word Achilles. Would we expect that the word Achilles is going to occur multiple times in that list? Yes, it will, okay? And that means that I've got duplicates in there, and that's okay, okay? That's maybe a good thing. Okay, so the other thing I'm going to do before I actually do the appending, okay, is what did we notice with the word sing, for example? When it had that comma, okay? What other things might we run into that are tacked onto an end of a word? Periods. Okay, I want to be careful with apostrophes. Maybe in English I don't have to, but in Greek I definitely do. Okay, but point being, can I go ahead and just remove the commas, periods, exclamation marks, colons, semicolons, anything like that that appears? Yeah, okay. So here's how I can do that and rid ourselves of them, is if a word, I can use the replace thing for a string. Okay, now let's do the comma first. And you guys are going to hate this, right? So, because look at that. So what have I done? What is this saying? And this is why I like using VS Code or any other like rich text IDE, because the color coding makes this easy to see. The white comma is part of the code, and it's going to separate two arguments that I'm giving to the replace function. What needs to go before the white comma? What I am replacing, and what goes after the white comma? What I'm replacing it with. Okay, so I am replacing any substring that is just a comma with what? Nothing. Okay, so essentially I'm deleting the comma. Okay, and I know that's kind of a mouthful when you look at it. You're like, wait, what? Okay, but just slow down, right? It's not rocket science. Maybe it is. We can do some rocket science. It's not that hard. Well, it's kind of like, okay, maybe I shouldn't say this when I'm live on Twitch, but building a nuclear weapon, not that hard. The hard part, getting the uranium or the plutonium, right? But building a uranium-based nuclear weapon, not that hard, except for the getting the uranium part. Okay, and it's got to be relatively pure uranium, like 80% U-235. That's the hard part. Yeah, maybe a little. I mean, so you guys were all in high school, right? High school yearbooks, do they still do the thing like who's most likely to end up as president and who's most likely to do whatever, right? Well, when I was in high school, I was voted most likely to take over the world. Okay. And my picture in the yearbook, I'm in camouflage, standing on top of a Marine Corps footlocker, and I have my hands stuffed in my jacket like I'm Napoleon. So, yeah. Anyway, okay. So that's going to remove the comma, and or if there's a comma at the end of a word. So what else could we do? Let's do the same thing for if there's a semicolon or if there's a period. or if there's an exclamation mark, or if there's a colon. Okay, and you guys get the idea, right? I can add whatever else that we find dirtying up our data. Okay, so, right. So basically, what is this double for loop going to do? It's first going to pull a line of the text. It's going to transform that into a list that contains all the words of that text. For each word in the text, we're going to pull off any of these extraneous characters and add that word to our big list of all of the words. Okay. All right. And if there's anything else, we can, of course, go back and add to that. Okay. So then when this whole thing is done, oops, where's my keyboard? There it goes. Let's just print the list of words. Okay. Now this is going to be a very large list, right? Okay. And we're only seeing, of course, some small part of it, right? Whatever happened to be at the end. Yeah. Question? Oh, okay. So this can sometimes happen if, and Thomas, I wonder if the same thing happened for you. So if you, did you edit the file? Okay. What did you edit it with? Okay. Notepad, and the same thing is true about text editor on Mac, can actually edit in two modes: rich text mode and plain text mode. And I bet you did it in rich text mode. Okay, so open it back up, and in file or edit or something, there's usually an option that says make plain text. Do that. Okay. I know that option is there on text edit within a Mac because I use a Mac. Okay. So what's the difference between plain text and rich text mode? The rich text mode is going to have crap for fonts and what size the text is and all of that. Do we want any of that? No. We just want plain text. I just want to know the characters. I don't care how they're formatted. I don't care what font. Okay. And so if you're getting errors like that, that would be my guess as to what the issue is. Okay. Yeah, question? VS Code should do it still as plain text. Yeah. All right. Well, let me look at it real quick. Did you copy and paste it from the?
No, I deleted everything else.
Ah, here it is. This is why. Select encoding. You see how it says UTF with BOM? I don't know what the BOM is, so we. I'll have to look at that. Let me come back to it. Okay. Okay. So yeah. So this of course requires that you have an actually well-formed piece of text to start with. Okay. But all right. Let's just keep going, and we'll deal with all those issues later. So do I have here my list of words? Okay. And actually, this is why I wanted to be a little bit careful with apostrophes, because you do see what's one of the words clanged, right? And so if I didn't want to split that, because that's actually one word, not two. Okay. And all right, so I've got a list of words. I also have like white armed there because I didn't split at all using dashes. Whether or not that's a good idea, I don't know, but we'll just run with it. Okay. And so I've got this gigantic list here. So one of the things I might want to know is, for example, how many times does a particular word occur in this text? right? Achilles, for example, we would expect to occur a fair number of times in our given selection, okay? And for that matter, how many words are there? Well, how many words are there is just the length of this list. Okay, so let's just print how many words there were, which is basically just the length, right? Oh, and I don't know why the Python extension is not loading today. Okay, so what do we get? 525 words. Okay, does that seem reasonable looking at the chunk of text that I pulled? I basically just pulled the first, page or two worth of it. Okay, so look reasonable? Yeah? Okay, question. Yeah, so the new line character, if you see \n, that usually means that's representing the new line character. And depending on how the thing was encoded, that may be, yeah, I'll look at that. Okay. Oh, the same way we did this other thing. Yeah, that's probably fine. Okay. Okay, so I've got all these words, and one thing we could answer is, well, how many times does Achilles occur in this particular list? Several times, probably, but how could I figure that out? Well, sort of, okay. Let me comment this out so we don't get it. But what do I need to do? I need to go through the list and check each word, and if it's equal to Achilles, then I need to add one to a counter. Yes? Okay, so let's just take the word Achilles and do it with this. So what I need to do is for each word in my list of words, if word is the same as Achilles, then what? I just need to add one to a counter. That counter should, of course, start at 0 because I haven't done anything. Okay, and when all is said and done, let's just print this. So the word, the word Achilles appeared occurred however many times. Okay, why am I doing string of count there, by the way, instead of just count in the printing? Yeah, I can only concatenate strings with other strings, and a number isn't a string unless I turn it into one, and that's what that string function does. It just takes the number and replaces it with a string that has those digits so that I can tack it on to the end of the string, okay? Okay, so will this work? Well, let's run it and find out. So what do we get? Okay, for many times, maybe that's bad English, but, right? So Achilles appeared, there were 525 words, and Achilles was 4 of them. Okay? Okay, well, if we can do this for one word, can we do it for all of them? Yeah? So could I produce, yeah, Mark? I don't think so, because Achilles never occurs in lowercase in this text. If that were the case for something like sing, then yes, I would have to check for either the upper or the lowercase version. But actually, fair question. Let's find out. I don't think it is in this text, but all I could do is just say or, right? Let's just check the lowercase version while we're at it. And it's still 4. Okay, yes. Oh, no, it doesn't. And that was just me being sloppy. So now you can use, and this is, yeah. So Python allows you to delimit a string either with single quotes, double quotes, double quotes, triple double quotes, doubles. Yeah, so there are multiple ways to delimit a string, okay? And the reason that Python does that is because what about if you have a text that has quotes in it, right? This way you could have a string that has quotation marks in it and not mess that up, okay? Okay, so in the case of Achilles, it only ever occurred in the capital version here. But if we replace this with a word like sing or death or something like that, then perhaps there would be a difference. Okay, yeah. Yeah, we could. We could just uppercase everything, okay, and then like take the word and uppercaseify it and compare that with the uppercaseified version of Achilles. And to be clear, what is the uppercaseified version of Achilles? All capitals, right? For Achilles, and just compare that way. If we could do it for all caps, we could also do it for lowercase, right? Either way. Okay, so yes. Yes, because we removed all of those up here, right? So they no longer have those things attached to them because we removed them. Now, that said, it's possible that I missed something. For example, Achilles, let's say, is there ever Achilles with an apostrophe at the end of it? Like Achilles in the possessive. I wouldn't actually catch that because it would appear as a different word because it's not. What does double equals mean when I'm checking this here? Exactly that string, okay? So I wouldn't be able to catch Achilles in the possessive here. That would be, for our purposes, a completely different word, okay? Now, is it really a completely different word? No, but we can do one other thing here in a minute that will help us tease that out, okay? Okay, so good. So if I can count this for one word, I can count it for all of them, right? Okay, and in particular, let's make a list that's going to be what I'm going to call deduplicated. You guys mind if I delete this? Yeah? Okay, so let me make a new list that I'm going to call deduped list, and it's going to start empty. Okay, and what I'm going to do is I'm going to go through my list, and I'm going to make a new list that has each word that appears, but with no duplicates. Okay, why do I want that? For something that we'll do afterwards. Okay, so for example, the word Achilles in my master list only appears 4 times, but in the new list that I'm going to construct will only appear once. Okay, is that okay? All right, so how am I going to do this? Well, let's see. For word in list of words, okay. This is really, I love Python that you can do this. Go through the big list, pick out a word, go through the dedupe list, If the word you just picked out is not already in there, add it in. If it is, don't do anything. Okay, so this if condition, right, there is, right, and we've used this when we do something like for I in range, blah, 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 or for word in list of words. Well, if a word can be in a list, it can also not be in a list, right? That's a Boolean expression. So if the word's not in the list, throw it in the list. And if it already happened to appear in the list, don't do anything. Okay. Now, this will result, by the way, in our deduped list, it won't be deduped by capitalization. Okay. So, for example, capital Apple and lowercase apple will appear as two separate words. We'd have to do some extra stuff to sort that out. But maybe we do want to keep those separate. But with words like sing, maybe we don't. Right. So we have to have some knowledge of the text to be able to go any further. Okay, so is that good? Okay, so if I print, what's the length of this deduped list? Let's just see what we get. 316. Okay, so what does that mean? There are 525 words in our chunk of text, 316 of which were unique. Okay, with the possible exception of the capital versus lowercase. Okay, so it may actually be slightly smaller than that. Huh? Okay, so it's not a huge number, but yeah. Okay, so let's just look at actually what the deduped list is, and I'm actually going to do something even more clever, which is I'm going to sort it. Right? So this is going to sort my list in alphabetical order, and then I'm going to print it. Okay, now this is going to be a very long list, so all right, so let's go to the beginning and just see what happens. Okay, so what if we messed up in one case? So here's just the beginning of it, right? So what did we just notice? Yeah, I never removed any parentheses, so we've got the word so with parentheses. Also, there's Jove down there, right? Jove with parenthesis and Jove without a parenthesis. Okay, so we could clean that up a little bit. But what do you notice about the way it's sorted this? It's alphabetically, but it's kind of quasi-alphabetically because what else appears? All of the cases count for the sorting, okay? And the reason is, what's the sorting method? Where do the capitals occur in ASCII? Yeah, they come before the uppercases in the ASCII. So it's sorting them basically based on their ASCII values and doing so. What was our big SAT word from last time? Lexicographically? That word? Yeah? Do you guys, what did lexicographically mean? Okay, how are words sorted in the dictionary? Well, yes, but like, so does aardvark appear before apple in the dictionary? Yes, because aardvark is AA and apple is AP, blah, 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 right? So it is sorting them lexicographically, but also taking into account case. So it's sorting them lexicographically, basically based on their ASCII values. And that's why the dudes with the parentheses go first, okay? Because the parenthesis is lower than the letters in ASCII. And we forgot to remove the parentheses. Okay, so I've got them sorted here. That's great. But you know what would be even more useful? What about if I had a list that had the word followed by the number of times it occurred in the text? Okay, so we did that for Achilles, right? We realized that Achilles occurred 4 times. Although actually he really occurs 5 times because I knew this was going to happen. Or not Achilles. It occurs, where is it? There's one of these where it's, well, yeah, because we've got like Jove and Joves. In this case, only preems occurs, not preem just by himself. Okay, but yeah, okay. So, or Achaean and Achaeas, should we count those as 2 separate words? That's debating. Yeah. Well, you could get rid of them the same way that I did here. Right, or you just go in and edit the text, yeah. Yeah, the strip method also works. Yeah, although I don't like to point out that you can strip in class, so yeah. So yeah, it's fine. Okay, so right. So I've constructed this deduped list, okay, and let's make a new list that's going to have each line or each entry in this list is going to be a word followed by a number, okay, and it'll be a word that appears and how many times it appears. Okay, does that make sense? Okay, so let me not print the deduped list. And while I'm thinking about it, let me go up here and get rid of these parentheses. And if I can do it for the left parenthesis, I can do it for the right parenthesis. Yeah, the strip function would probably be a lot more convenient here. Okay, so that'll deal with the parentheses business. And all right, so now what I want to do is, let me get us a little bit more space here. I'm still going to sort the list, but I'm now going to make a new list. And I'm going to call this word count list, and it's going to start empty. I'm going to go through the deduplified list, and I'm going to count how many times the word appears in my master list. Okay, how did I count earlier how many times the word Achilles appeared? I actually wrote a loop and did it manually. But there is a built-in method to do this, and it's just the count method. Okay, so if I do count equals list of words dot count of word, it's going to go through the list of words, which has all 525 of them, and count how many times the given word appears, and then make that as a number. Okay, so for Achilles, this would have ended up as what, 4? Okay, all right, so that just gives me the number, and then what I want to do is I'm going to append to my word count list the following thing. I'm going to append, okay, and I'm actually going to make my my list a list of lists. Okay, so I'm going to have the word followed by the count that goes with it. Okay, and let's not print that one, but let's instead print the word count list. And let's see what we get. Okay, so here we are at the end, and doesn't really matter which words we look at, but what do we see at the end? The word the appears how many times? THE. In this case, 27. Okay. Or the word you appeared how many times? It's down at the bottom, 1. The word ye appeared twice, and so on. Yeah.
Can we sort by like the highest number of
We could actually, yeah. So we could redo this and make it in order of most frequent word to least frequent word. We'd have to write a new loop to do that, though, and there's not going to be a magic way to do it. Okay. Yes. No. No. The capital versus the lowercase are still different. And which is okay, right? I mean, we just want to get the idea. Like, does it really matter what numbers we get out of this? No, I mean, it's the idea of how are we processing through this text that's important, okay? Okay, so, great. Now, for the final act, yes. Oh, are you doing it from the main list of words or a different? Which word list are you using though? Really? And you're getting zeros? That's weird. Well, I'll look at it in a minute. Yeah, that's weird. Okay, so yeah. So is this particularly helpful to us dumped out into the console? What would be more useful? A table, or could we throw this in a text file? Right? Okay, so if we can read lines from a text file, can we write lines to a text file? Yes, and so now that's the last sort of act I wanted to do. Okay, so yes, a table would be useful. We've already got the data basically ready to be built into a table, but for the same token, I could also just dump this to a text file. Okay, so if I want to dump this to a text file, I first have to open a new text file to be our output. What'd you do? Yeah. Okay. You fool, you fell for one of the classic blunders, right? Okay, so I need to open a new file. In this case, it's also a text file for writing, and so hence why I have the W there for the mode. It is possible to open a file for both read and write simultaneously, but do so carefully. Okay, there'll be dragons. Okay. All right. So I've opened the file. Now, how do I put stuff into it? So down here at the bottom, when I appended something to my list, I can also write it here. Okay. And here's how I'm going to do it. I'm going to do output text dot write. And what am I going to write? I'm going to write a string, and that's going to be the word followed by a colon and a space, followed by the count turned into a string, and then I have to do this, followed by \n. Okay, so let's think about what's inside the parentheses there. What I'm writing to my file is a string, okay, which means I'm writing a bunch of characters. Okay, what are the first chunk of characters? They're whatever word I'm currently working on. Okay, I then want to add a colon and a space to format it nicely. Okay, and then I want to add the count, which is a number, so I have to turn it into a string so I can concatenate. And then what does the \n do? What do you guys think? New line, okay? Because if I don't have that, I'm going to end up with a file that has just all of this crap on one single line, and that's kind of useless for us as humans to read. Okay, so is that okay? So I know it looks a little bit blech, but yeah. Okay, and then what have I forgotten to do? I've already do as I say, not as I do. I never close the damn file. Okay, so if I all right, so let's run it, and what's going to appear now? Oops, sorry, is, hey, look, a new file is there. And look, Achaean, 1, Achaeas, 1, Achilles, 4, Hades, 1, against Agamemnon, and part, Apollo, Argos, and so on and so on and so on, right? That's kind of cool. Yeah. So there it is. We just wrote it as a text file. That's neat. Okay. Now, I think Mark's question was, wouldn't it be better to actually sort this by frequency rather than alphabetically? Yeah, we could do that too. We'd have to, do some extra stuff here because we don't necessarily know in advance what order that's going to be in. We have to compute them and then start to sort them. Also, we haven't really handled the upper versus lowercase thing in any elegant way. We could, maybe think about how to do that if in a more nicer way if we just threw more time at this. Okay. All right. So for my final act today, I wanted to show you guys briefly. Okay. I wrote all this same code yesterday, and I tested it on ancient Greek instead. Okay. And I wanted to talk just briefly about what's going to be the difference about doing this with ancient Greek, or for that matter, anything that's in Unicode versus stuff that's in ASCII. Okay. And the answer is not as much as you might think. Okay. Good. All right. So for that, I'm going to switch over to my Mac, and I'm going to put this VS Code on that screen. Okay. And basically the code that I have is exactly the same as what we wrote together. The one exception is there weren't parentheses and stuff, so I don't have as many replacements going on. But literally, this is the same thing, okay? And so if I run it, then I get some output, okay, yay. And here, the deduplified list that's printed, let me actually open it here, okay, is, essentially the same thing. Okay, I took about the same number of words out of the beginning of the Iliad, except, well, they're in Greek instead of in English. Okay, now that points out something kind of interesting that we don't really have to worry about as much in English. What are the very first two words that you see up there? Well, how many of you guys can read Greek? And the text is maybe a little bit small. Let me blow that up real quick, so it's easier to see. All right, what do we see? The very first two first words. All right, the first one is danioi, and the second one is danaon. They're the same word, okay? But Greek grammar works differently, and the endings tell you how the word appears and functions in the sentence. So here I've counted them separately because they do look like they're different words, but are they? Not really. Yeah? Okay. No, it's they're both capitalized because they both start with a capital delta. It's danaoi is nominative plural, and danaon is genitive plural. Okay, so it's how they function grammatically in a sentence. And you wouldn't know, you would have to know Greek to know to tease that out. Okay, now the last thing, and then I promise we'll quit, is I want to show you guys how this text is actually encoded. Okay. It doesn't look like it's readable. And the reason is that Unicode has to get stored. It takes for all of the Greek characters, well, some of the Greek characters, it actually takes more. A character can take anywhere from 1, 2, 3, or even 4 bytes to store. And it depends on where it is in the Unicode code point base. I'll link to a Wikipedia page if anybody's curious about how it works. It's kind of clever, but Yeah. Okay. All right. See you guys on Tuesday, if not sooner.